Hi everyone, this is Paolo Tezzon and I am the Research and Development Manager for Diapason loudspeaker system from Brescia, Italy. And I'm very happy to welcome you into this fourth episode of the series of short video clip that we are shooting in order to convey you all the passion, the dedication and the thinking behind that we placed in our latest design, which is the Didascalia, that you can see right behind me. Didascalia represents for Diapason sort of manifesto project, something that we put in place in order to create a milestone for the years to come of the history of the Diapason brand. In fact, as you might see in the previous episode, which I highly recommend to watch in the right order, we designed from scratch our own transducers thanks to the help of Scanspeak Denmark. In fact, in the previous episode, we put a spotlight on the tweeter, on the mid-woofer, on the drone units and the system to manage them. In this episode, we're going to talk instead about the crossover network, which also has some peculiar solutions. The crossover network is the brain of any given passive electroacoustic device, and because it is the circuitry which allows to glue together the contribution of the different units and to voice, according to our taste and according to what we believe is the best, the sound of a loudspeaker system. The choices we made for the crossover of Didascalia, which you can see right here in my hand, are, like it happens for every single detail of the system, extreme. Because right here we have a crossover network which is based on a balanced circuitry, first of all. The typical crossover network, in fact, are single-ended circuitry where the reactive components, being them capacitors and inductors, are placed in parallel or in the positive rail of the circuitry. In this case, dealing with a balanced design, we have reactive components which are placed both in the positive and the negative rail of the circuitry. And again, this is a state-of-the-art choices in itself because you are using double the components to doing the exact same job from the electrical standpoint, even if, obviously, such a choice brings some beautiful and helpful side effects when it comes to music reproduction. But let's start talking about the circuitry topology we chose in first place and the kind of filter more specifically. We decided to go on for the tweeter and for the mid-woofer because we made two different choices. When it comes to the mid-woofer, we wanted to have a behavior as free as possible. We wanted this amazing transducer be able to express itself without limitation and without constraints in the broadest frequency range possible. In fact, we are using a first order design. This means having a very gentle slope with a decay of 6 dB per octave of the low pulse as soon as we reach the crossover frequency. On the other hand, we wanted to have a very tight management of the tweeter. We wanted the tweeter to do its job and its job only, without giving any contribution in frequencies which are not supposed to be performed by such a transducer. Therefore, we decided to go on with the fourth order design. This means having a decay of 24 dB per octave once the crossover frequency is reached. So very different choices. And as mentioned before, each of the two circuitry are balanced design. This means no matter having just two components, we have a pretty crowded crossover network. What are the benefits of a balanced design? There are two main benefits. First of all, any crossover network traditionally designed, meaning single-ended, has the tendency of behave like an antenna. Therefore, they have the tendency to capture radio frequency pollution, which can create some dirt, some interference with the purity of the music reproduction of the signal path. A Balanced design is supposed to overcome this problem and to provide already a solution with avoiding this antenna behavior of the crossover network. Another reason Another benefit of a balanced design is supposed to be related to a topic which is a debate among the electroacoustic community these days, the so-called look-back impedance. When we think about impedance, we always think about the impedance as seen from the amplifier perspective, seeing the speaker as a load, which is obviously correct. But on the other hand, there is another kind of impedance, which is the impedance represented by the amplifier as seen from the speaker perspective. And this is also, according to some debate going on among the electroacoustic scientist community worldwide, this is something that has to be taken in account. And such a crossover configuration takes in account exactly this topic, providing the best possible coupling with any given amplifier. Another important thing to mention are the choices we made in terms of components, because not only we went with the most expensive solution, talking about the balanced design, which come as a consequence that you have to double the amount of components to achieve the same electrical result. Same, so to say. But also we choose to use the best of the best in terms of components. So right here we have an hardwired point-to-point circuitry avoiding any PCB, and this means a lot of work for setting up any crossover, but avoiding a PCB means having the purest signal path. And then we have Janssen inductors, particularly the cross coil, which is a copper laminar coil wounded around a wooden core, which has an amazing performance in the midband. And then we have Mundorf resistors and capacitors. We have the supreme resistors to manage the sensitivity of the tweeter, and those resistors, they cost like an expensive capacitor. They really cost a lot, but the result they provide in terms of transparency is stunning. And then we have Mundorf Evo silver gold oil and Supreme silver gold oil capacitors to manage the tweeter. Of course, everything is completed by these wires, which are wiring the whole speakers. Those are the CS12 Van den Ull cables, and I would like to point out that any Diapason loudspeaker, from the Mi Micra to the Dynamis, is internally wired using Van den Ull cables. Another detail which makes the difference in the performance Diapason speakers are able to provide to the music lovers. The last touch of such a component is that now you can see it, but you have to imagine that before mounting the tweeter, we literally cover the whole circuitry with a resin which after a while becomes thick as a brick, avoiding any sort of vibration, any sort of spurious noises coming from the crossover network itself. Thank you very much for your attention, and see you in the next clip. Goodbye.